Hello everyone, welcome to SYNTHFOX channel. This is Astro, and today I will be presenting you my new module called Passive Tools 2. This is a set of passive utilities, much like Passive Tools 1, but while Passive Tool 1 concentrate on being universal and processing different kinds of signals, Passive Tools 2 is more of a set of well-defined utilities with certain purposes. It has 4 sections. First one is called Tap. It has an input, an output, and a range switch. Its main goal is to make pluck decay envelopes out of gate and trigger signals, but it can do many more. Next up is the LPG, which is a passive low-pass gate with a homemade Vactrol. It is DC coupled and can be used for sound and CV processing. It has a CV input, a signal input, and the output. The third submodule is called Bend, and it's an esoteric passive wave shaper-ish kind of a section. It's mainly aimed for use with sound, but can process LFOs as well, and it enriches harmonically poor sounds like sine waves and triangle waves. And lastly, we have the LPF section, which is a low-pass filter with an input, an output, and a toggle switch which selects between 3 preset cutoff frequencies. Let's review each one of these sections one by one. First on the module is the tap section. It tries to detect a rising edge of a square wave and convert it into a sharp pluck envelope. The length of the envelope can be controlled with this toggle switch. In the middle position, it's the sharpest and shortest one. In the left position, it's the medium one. And the rightmost position is the longest one available. Let's first try it by picking a square wave LFO and putting it into the input, then taking the output and putting it to the filter audio input. Then we take the filter output and put it into our audio mixer, and let's hear this very nicely shaped, plucky kind of a sound. Let's see how different lengths of this decay envelope affect different modules may require different lengths, so this one seems to be working the best with the medium envelope, but for example the LPG only reacts to the longest one, which is on the right. So let's try it with something else. I remade the patch, so now instead of plucking the filter, the tap output is actually pinging the Vactrol low-pass gate, which has the sine wave VCO as its input, and it goes to the mixer right there. Let's hear different lengths. As you can see, it almost does not react to the shortest one, although this filter did, so. But the medium one, and especially the long one, seem to be doing the best. Of course, you can do many more with it, so let's hook up something more interesting. Here I made the patch a bit more complex, so instead of a simple square wave LFO, we will be putting a random output to the tap section. So instead of detecting a rising edge of this square wave LFO, it will try detecting when this output rises and ignore when it falls. So what we should be getting is kind of rhythmic patterns with different velocity at the output. Let's see. As you can see, it gets interesting really quickly. You can of course use any sorts of signals to process through the tap, Especially it works well with LFOs, sequences, random voltages, and other stuff that has sharp edges. But of course you can try, for example, putting a sawtooth into it or anything else and see what happens. For instance, right now I put a sawtooth into it from the VCO, and we will hear how it affects it. It acts like a weird high-pass filter, which is sometimes also musically useful. Next up is our LPG section. It has a CV input, the signal input, and the signal output. The signal input is DC coupled, so you can pass both audio and CV through it. And let's try it with a built-in tap function. We will first trigger the tap section with an LFO, then we will pass the tap output as CV to the LPG, and let's use some sine wave as the input, and the output of LPG goes to our audio mixer right there. Works perfectly fine. We're getting that iconic LPG bongo. So here I hooked up another patch, which is a sawtooth going through the VCF and to the mixer. Let's say I want to control the filter cutoff with an LFO right there, but I want to do it in a slightly more creative way. So let's do it with the help of an LPG. We will pass it to the signal input, and the signal output would go to the filter right there. Nothing happens so far because we need some CV to open up the LPG. Let's use this envelope right there, and we will trigger it with an LFO. So, adding dynamics to your control voltages, easy and quick. Now let's see what the Bandsaw Module does. It's best audible on the most harmonic poor wave, which is the sine wave right there. Let's listen to it before we proceed any further. And now we put it into the band input, and the band output goes to the mixer. As you can hear, it got harmonically enriched and does not really resemble a sine wave anymore. The same thing will happen to all common wave shapes with continuous voltages like sawtooths and triangles. So let's see. Sawtooth, triangle wave gets a very evident additional bunch of harmonics. But the most fun is to control the volume of the incoming signal before putting it to the bend, because then the wave shaping will happen differently. So let's use the LPG for it. We will use the LPG output to the bend input, and then to the LPG input we put our sine wave, and then we will control the LPG with our envelope, which we've just used. Let's trigger it with an LFO. So, boost it a little. I'm specifically using an envelope generator instead of the LFO to control the LPG right there, because it only accepts positive voltages. It will simply ignore the negative portion of the voltage, and since the LFO is bipolar, it will not be as interesting, and the envelope generator is unipolar and has a nice shape. Last but not least, we have the LPF section, which is a low-pass filter with 3 preset cutoff frequencies selectable with this toggle switch. It is a very important tool in mixing in your patch, and it actually complements the Passive Tools 1's high-pass filter portion. So let's hear how it sounds. I'll test it on some white noise, so that the cutoff is very evident. In the middle is the highest cutoff frequency. Most of the sound passes if you select this one. To the left is a slightly lower cutoff frequency, which already makes the sound more dull and dark sounding. And to the right is the most low cutoff frequency, which almost does not pass any sound, only the lowest harmonics and frequencies. For example, when you want to mix a bass and a synth line, it's sometimes wise to put this low-pass filter on the bass portion so they wouldn't overlap while being mixed down together on your mixer. So I set up a little patch here, which has this sound going on in higher frequencies. And let's suppose that I want to add some white noise to it as a background layer. Now, it sounds noisy and messy, doesn't fit at all. Let's put it through the low-pass filter. Way better. Let's see the other cutoff frequencies. Now this sounds alright. Much more clean. This one needs to be boosted a little. But now it all fits together very nicely. As well as this one. Cutoff frequencies. This one is the most open one in case you have a bucket brigade delay, because those are prone to producing those high-pitch sounds, and this low-pass filter was actually designed to remove that. And then afterwards, I decided to add different cutoff frequencies, so it could also be musically useful in other cases. So, dear bucket brigade delay users, now you can denoise your BBD. And so that's pretty much it about my new module called Passive Tools 2. It has 4 great sub-functions in just 4 HP, and I hope you have a lot of fun exploring the music and things around you with this module. I've been Astro, this is SYNTHFOX channel. Thank you so much for joining me today, and see you next time.